Hey guys, Mr. Beckstrom here. Today I want to take a look at a couple of problems from section 3.9. This is on finding derivatives of logarithms and exponential functions. So I think I pulled up some examples from number 9 and number 10 in our homework here. So the first one here says use properties of logarithms to simplify the following function before computing the derivative here. So here we have f of x is equal to the natural log of 8x plus 1 raised to the 6th power. So we don't really have a good way to find the derivative while this is raised to an exponent. But luckily, we know that when we have a logarithm, we can pull that exponent out front. So that's what we're going to do here. So this is going to go ahead and write this as y is equal to 6 natural log of 8x plus 1, like this, just pulling that 6 out front. And now this becomes a super easy problem. So now we can go ahead and take the derivative. And the derivative of the log of something is 1 over that something times the derivative of that something using the chain rule. So here's the inner function, and then the outer function of the derivative of a logarithm is 1 over whatever's in the inside. So we keep the 6 there. So the derivative of the outer function of the log of that something is just 1 over that something. So 1 over whatever's in there. This is the derivative of the outside function times the derivative of the inside function. The derivative of 8x plus 1 is simply 8. And we multiply all that together, and I think we're going to get 48 on the top, 6 times 8, and on the bottom, we're going to get 8x plus 1. That's it. So a nice, easy one here. All right, let's take a look at another one. So here it says compute the derivative of the following function. And I've got 8x e to the negative 5x. Now there's a few ways we can go ahead and approach this. I can use the product rule. Now I can either pull out the 8 and just use the product rule with the x and the e to the negative 5x and then distribute the 8 back in later. Or I can just call the first function 8x, which is what I'm going to do in this case. Or if I wanted to, I could pull the e down to the bottom and use the quotient rule to make that a positive 5x, but that's more work than it has to be. So what I'm going to do is just call my first function 8x and my second function e to the negative 5x and work it that way. So doing that, my first function, oops, go ahead and do this. My first function, I'm going to define that as 8x. That means the derivative of my first function is simply 8. And my second function, I'm going to define that one as e to the, it was not a very good e, was it? E wasn't much better, but I'll take it to the negative 5x. And the derivative of my second function, oh, and I put a little derivative for that first function there, is going to be using the chain rule, so the derivative of the outer function, which is just e to the minus 5x, times the derivative of the inner function, which is just going to be negative 5. So I can simplify that to just negative 5 e to the negative 5x. And now when I apply the rule, which the product rule for derivatives says the first times the derivative of the second plus the second times the derivative of the first. That's the symbol that I like to use. You can use whatever you want. So this is 8x times the derivative of the second, so times negative 5 e to the negative 5x plus the second function, e to the negative 5x, times the derivative of the first, which is just going to be 8. So clean this up a little bit. I'm going to get negative 40x e to the negative 5x plus 8 e to the negative 5x. Now I know that we usually only leave positive exponents, and that might be how MATLAB would leave it. But for me, if they left the original, or if the original problem had negative exponents, I'd probably leave this one like that. If they didn't take it that way, then I would put it like this. Negative 40x over e to the, actually, we could just combine those, can't we? E to the 5x, and then over 1 plus 8. Just like that. All right, so if you have any questions, let me know, and I hope you all have a great rest of your week. Thanks.